Welcome to Ask and Learn.
Suppose that f and g are continuous on the closed interval from a to b and differentiable on a to b. Suppose that f of a equals g of a and f prime of x is less than or equal to g prime of x for a less than x less than b. And we are being asked to prove this statement right here, f of b is less than g of b. Okay, so the first thing we have to do in this problem is we're going to assume what the statement says, h equals f g, so we're just going to rewrite that, h of x equals f of x minus g of x. That's a g. Okay, so now since we are already told that that these two functions are both continuous and differentiable, we can apply the mean value theorem right away because those are the conditions required for the mean value theorem. So we're going to apply it to h of x. We'll get h prime of c equals h of b minus h of a all over b minus a. And then we can rewrite this because we have h of x, since we assume h of x is equal to f of x minus g of x, we can actually rewrite the left side and the right side. We can write f prime of c minus g prime of c. And since h of b, we can also rewrite that as f of b minus g of b. And this is one group. And then minus. And then we can do the same thing with f of a minus g of a. And just remember, these are just substitutions we're doing. These are all coming from the initial assumption we made earlier. Okay, now that we have this statement, we are also told that f of a is equal to g of a, so we can automatically, since f of one, the same number minus the same number is 0, we can just put a big 0 right here because that is the same thing. We're told that. And then what I'm going to do here is I'm going to bring this b minus a on this side. So I'm going to rewrite this. We're going to bring this to another page. I'm going to have b minus a times f prime of c minus g prime of c equal f of b minus g of a. F of b minus g of b. Sorry about that. And now also going back to the first page, we are also told that f prime of x is less than or equal to g prime of x. And since g prime is greater and it is negative, this left-hand side is negative. And we can also assume the same thing for the right-hand side. This is also negative. So when something is negative, we know that it is less than 0. So we can rewrite the right-hand side as an inequality sign. So this is going to be less than 0 because that's what this tells us. And then we can bring this over. We can add g of b. And bam, we have now proven that g of b is greater than f of b for all x in this interval from a to b.